What I mean by alternative method is that the method we used before will fail when you have type B and type C in some cases, and improper fraction is a mixture of A, B, C, basically. So, what do we do when that method fails? It's simply using our previous knowledge of what we know before now, then we put it that way. So now, everything you are doing from the beginning is the same up to this point. But rather than substitute something that eliminates A or B, you expand the brackets. We expand the bracket and we compare the coefficients. So this is what I mean by that. So 4x plus 12. This is 2ax, yes? Tell me the next.
Plus 3a
Uh-huh.
plus 2bx
Mm-hmm.
plus 3b.
Alright. So you collect the like terms. This is still 4x plus 12. So this is 2ax plus 2bx minus 3a plus 3b. From here you can compare the coefficients of x on both sides. If you think you don't want to, you can go one step further. If you think it will still be confusing. Now the step I've written in blue is not necessary. So I'm going to do this. I factorize x. Can you see that? So I can see this as the coefficients. Or you could just pick it directly. Anyway, minus 3a plus 3b. So that step is not necessary. Okay? So you can jump from here and compare both sides. If I compare both sides, so you pick from here, oh, this has x, 2a. This has x plus 2b. Here, this has x is equal to 4. That's your equation 1. Then from the other one, negative 3a doesn't have x. Plus 3b doesn't have x. What doesn't have x here? 12. So I think from both of them we can actually divide through. So from the first one, we can divide through by 2, and we're going to get a plus b equals 2, right? We can also divide the second equation by 3, and we get negative a plus b equals, alright? So we can solve by so if you had, I can add this 2, a is gone, and I get 2b equals 6, and b equals 3, just like we got before. If you subtract, b is gone, then you get 2a equals negative 2, which you get negative 1, just like before. So this is the alternative method. Expand and compare both sides. Yes, method. Yes. Now that method is useful here. Now why doesn't it's why is it very useful? Please, I would like you to complete that in your notebook, but I just wanted to show you. In quadratic, this type, when you have denominator as quadratic factors, I want to quickly go through this because it's not like A and B. When you deal with linear, this will be proper only if what you have, the degree you have at the top, is lower than the degree at the bottom, isn't it? So that is why when you have a linear, you expect a constant, isn't it? If you have quadratic, this is proper, correct? 1 over x squared plus 1. Similarly, this is also proper, 2x plus 1 divided by x squared plus 1. Am I right? Because here you have degree 2, degree 0. Degree 2, degree 1. Okay? Or maybe I put it this way. Yes, basically. So now, in this case, what it means is that even though you had your ax plus b, your a happens to be 0, and your b happens to be 1. That's why you only have this left. Okay? So the general format is to create that avenue for all the possibilities. Worst case scenario, the linear vanishes. But if you treat it as a constant, what if there is an x factor to be included? That is why the general form, when you have a quadratic non-factorizable, when we talk about quadratic factor, we mean non-factorizable. you have to look at it and say, can I factorize this? If the answer is no, then it becomes quadratic factor. Not just anything that contains x squared. I want to ask a question. Hopefully you have done it, or maybe not. If I have a general quadratic form, how do I know this is factorizable? I don't want to factorize, but how do I know I can factorize? Of course, A, B, C means a number, a random number. So for example, x squared plus 3x plus 2. Is this factorizable? Yes. What are the factors to use in the bracket? Speak louder, please. So 2 and 1, basically, right? If I have 3x squared minus x minus 4, is it factorizable? Minus 4 and plus 3. Their product is minus 12 and their sum is minus 1. So it's satisfied. Because the product must be the product of the first and the last. And the sum must be the median. So you can see that it took some of you some time to know that it is factorizable. I'm not asking you to factorize. I'm only asking you if it is factorizable. Why is this important? If you do not know if it is factorizable or not, you might be tempted to treat it as a linear problem or not treat it as a linear problem. What if this question is here intentionally? You're not supposed to treat it as a quadratic factor because actually they just need you to factorize it and put it as 2 different factors so you can have A, B, C. Does it make sense now? So that is what I'm asking. In general, how do you know that a quadratic expression is factorizable? Let's deal with ax squared plus bx plus c now. I'm not dealing with concrete examples.
Product of A and C has factors which sum makes B.
So it means it is still peculiar to the case. Like you have to see the product, you have to know what the products are. Well, you don't have to. This is the test for factorization. Once your b squared minus 4ac is a perfect square, then it is factorizable. Do you know that quadratic thing you do, right?
Yeah.
X equals minus b, right? Now, let me show you something else. Enough, please. We don't want to make too much noise. Thank you. You remember this? You can only factorize if at the end of the day this gives you a number. Because that number added to this or subtracted from it divided by 2a is what gives you those 2 numbers, be it whole number or fraction. Once this is a decimal, what does that say about factorization? It means you cannot have that concrete integer to be put here. You know there will be some integer here, then there will be some other integer here. So you don't have that concrete integer because you come up with a non-terminating decimal here. And you can only have a non-terminating decimal if your b squared minus 4ac does not give you a perfect square. But the moment you have a square number under the square root, it comes out as a whole number. Then you had, it's possible, it is not a factor of 2a that's allowed. So you end up getting 7 over 3, maybe 21 over 4, that's allowed. But at least it's a rational number. Do you understand the point? So the test for factorization is this a perfect square? So any expression of this form can only be factorized if your b squared minus 4ac is in the form of k squared, where k is a whole number. Does it make sense? That's all you have to check. So let's check this. B squared is 9. Minus 4ac is minus 8. That gives you 1. Is it a perfect square? So that's why this can be factorized. B squared minus 4ac in this case will be 3 squared minus 4a 1 2. And that's 1. Okay? In this case, b squared negative 1 squared, 4ac, 3 minus 4. Then you have plus 1, then plus what? 48, which gives you 49. A square number. So that's why you are able to find the factors of this. Okay? But if you check this problem, what is b squared? 1. What is 4ac? Minus 4ac will be minus 8. 1 minus 8 is negative 7. Is that a square number?
No.
No. So this is indeed a quadratic factor. But if I twist it and I make it like, for example, minus 2, and this is, will I not get a factor now? Yes, I will. If I get this minus 2. So the factors will be 2 and 1, basically. In that case, it will be 1 plus 8, which is 9. Then it will be factorizable. Then this will be a, b, c. Okay? But now, because it's not factorizable, I treat it as a quadratic factor. And because it is quadratic, put linear at the top. So linear means I'm going to have some constants and x with another constant. Now it's possible this is 0. And it's possible this is 0. But you have to create the room for it. Then the next constant will be c. And this is what we now solve. So the problem now is, now I'll show you the next step and we go for lunch in 2 minutes. This means, these are the LCM, right? Just tell me what it becomes when I multiply through, quickly. Brandon, are you sure we can see this? X squared minus 3x minus 7 will be, now this is a binomial, so it should be in the bracket, correct?
Yes.
Multiply by what?
2x minus 1.
2x minus 1. Then c will be multiplied by x squared. So, if you use the cover-up method, you substitute what here? Substitute what?
1.
1 over 2. Good. And that eliminates a and b for you to get your c. What do you know to substitute to cancel c? And even if you are able to eliminate c, can you get a and b at the same time? It means the cover-up method will fail. That's what I mean by that. And what do you now use at that point? The alternative one, the expansion.
Oh.
So it's allowed to use the cover-up method at first to eliminate the variables. So you use it once, you already have your c standby. Does it make sense? So then you expand. Once you have your equation in terms of a, b, c, the value for c is already known. Your equation becomes small, simpler. Does it make sense? So I'm going to leave this. I'll write a few steps. I'll leave the rest for you to complete. Yes, Randy.
So after you expand that, the whatever.
But before you expand, use cover-up method. Because you can get a variable by the cover-up method.
What do you mean?
Okay. Your cover-up method can be used here.
Yeah.
And that eliminates which of them?
The
A and B. So you can get what? C. So your C is standby.
Oh.
Then you expand because you can't use cover-up method anymore. Then you expand. So rather than getting equation A, B, C, because your C is known, you are back to equation A and B. Alright?
Yeah.
And it becomes easier.
Wait,
you may not even need to form simultaneous equation sometimes. But whatever, after you expand, you will see clearly if you really need to solve simultaneous equation or you just need to substitute C and B comes out automatically. Yes, quickly.
When you compare like terms, the one with x squared is going to be the same with.
It's going to be 1.
Okay.
The
So
one
it's
is
one
this
A,
minus
B, and
3. So this is what I mean. It's possible after you get your C, one equation, maybe A plus C is equal to 5. Because your C is known, you don't have to solve simultaneous equation. You just substitute and your A comes out from here.
Oh.
You compare the other one, so it's not always that you have to solve simultaneous equation. That's my point.
Okay.
Yes, quickly. Because this is linear. Degree 1. So you can only have degree 0. And remember, a number 7 is actually 7x to the power 0. So it has to be a proper fraction, which means the degree at the top must always be lower than the degree at the bottom. Any question? So this is where we stop. We will see on Monday.